Hey, what's up everyone? Welcome to Descriptive / Laboratory Chemistry Part 2. Today we're going to be talking about precipitation reactions. If you've never seen what a precipitation reaction looks like, here's an example of one of them. This is a chemical reaction here. And what's happening is that two aqueous reactants are reacting to produce an aqueous product and a solid product. Now, although it almost doesn't make sense for two aqueous reactants to produce something solid, this is actually a really common type of reaction. And this one in particular is a double displacement reaction. And you'll see that a lot of precipitation reactions are double displacement reactions. So a formal definition of a precipitation reaction is a reaction in which two aqueous solutions are combined to form an insoluble salt. And we call that insoluble salt the precipitate. But of course, there's a big question here. If I told you I was reacting silver nitrate with magnesium chloride to produce magnesium nitrate, NO3 and silver chloride, how would you know that the silver chloride here is a solid? How do you know what compounds are soluble and which ones are not? For that exact question, we have something known as the general solubility rules. And this is a list of the major ones that you need to know about. And they tell you ions and they tell you the rules for them. So for example, group 1 ions are always soluble and there's no exceptions for that. But if you look at something like chloride, bromide, or iodine, you're told that they're always soluble unless they're with silver, lead, or mercury. And you also have like certain weirder exceptions that come up, especially on these tests. And they're told here, something like lead chloride is going to be slightly soluble in cold water and moderately soluble in warm water. Okay, let's do a bit of practice with this. So let's say I give you tin 2 sulfate. Is this going to be soluble or insoluble? Well, first of all, we're dealing with sulfate, so we know that the rules that we really care about are going to be right here. We're told that sulfates are always soluble unless they're with barium, lead, calcium, or strontium. Tin isn't any of these, so that tells us that tin 2 sulfate is going to be soluble. And that's true. So let's look at strontium chlorate. Chlorates are right here. Chlorates are always soluble and there are no exceptions, so therefore this has to be soluble. Next one, silver bromide. Bromide rules are right here. So they're always soluble unless they're with silver, lead, or mercury. And one of them is silver, so therefore this is insoluble. And last one, copper carbonate. Carbonate is right here. Carbonates are always insoluble unless they're with group 1 ions or NH4, and copper isn't one of these, so that means this is going to be insoluble. So those are some examples of how you would use a general solubility rules table to determine whether or not a compound is soluble or not. And that's about it for precipitation reactions. Just keep in mind that precipitation reactions are usually double displacement reactions, and you need to use your general solubility rules to find out which one your precipitate is. So let's just go through one more problem. Which combination of dilute aqueous reagents will not produce a precipitate? So we have 4 different options here, and let's go through all of these to see which one is not going to produce a precipitate. So first of all, we have silver nitrate, AgNO3, reacting with hydrochloric acid. And we need to predict the products that are going to form here. Remember, these are usually going to be double displacement reactions, and so we need to do a double displacement reaction here. The silver pairs up with the chloride, so we have AgCl, and the hydrogen is going to pair up with the nitrate, so we have HNO3. If you look at the solubility rules for the nitrate, if you look at nitrate here, nitrate is always soluble and there are no exceptions. So the nitrate here is going to be aqueous. But if you look at the silver chloride, if you look at the rules for chloride here, they are right here. They're going to be soluble unless they're with silver, lead, or mercury, and we have silver here. So that means this is going to be solid. And therefore we do produce a precipitate here, and that means A can't be the right answer. Let's look at the next one, which is sodium hydroxide, NaOH, reacting with perchloric acid, HClO4, and we have to predict the products here. Again, it's a double displacement reaction, so the sodium is going to pair up with the perchlorate, and therefore you have sodium perchlorate, and you have the H pairing up with the OH, and you produce H2O. Obviously, you have H2O, which definitely is not a solid; it's just a liquid. And then you have to look at the NaClO4. If you look at the solubility rules for the sodium, sodium is always soluble, and there are no exceptions. So that means this one is going to be aqueous. Since we're not producing a precipitate here, we know that our answer is B. But just to be safe, let's go through the other answer choices too. So we have barium bromide, BaBr2, reacting with Na2SO4, sodium sulfate. So the barium is going to pair up with the sulfate to produce BaSO4, and the sodium pairs up with the bromide to produce sodium bromide. Solubility rules for sodium tells us that sodium is always soluble, so this is aqueous. And then the rules for barium and sulfate, if you look at the rules for sulfate, sulfates are always soluble unless they're with barium, lead, calcium, or strontium. And we have barium here, so that means this is going to be a solid or a precipitate. So C is also not the right answer. Let's just check D really quickly. So we have zinc iodine, ZnI2, with potassium hydroxide. The zinc pairs up with the OH, so you have zinc OH, zinc hydroxide 2, and you have the potassium pairing up with the iodine to produce Ki. If you look at solubility rules, if you look at iodine here, iodine is always soluble unless it's with silver, lead, or mercury, and we don't have any of those, so this is aqueous. But then we have zinc with hydroxide. If you look at the rules for hydroxide, hydroxide is always insoluble unless it's with a group 1 ion, strontium, barium, boron, and calcium is also somewhat soluble. However, zinc isn't any of these, so that means zinc is going to be a solid. And D is not the right answer, so our answer of B was right all along. That's all I have. I hope you were able to learn something, and I hope to see you later. Thank you.